Hi everyone, how are you doing? Okay, so yes, I'm also very much excited. So there are many messages that people are saying that they're very excited. So similarly, I'm also very excited to teach this course. So welcome everyone to the course of machine learning. And in this particular course, as you know, that we are going to have machine learning basics very right, which means we are going to deal with a lot of mathematics. We are going to deal with a lot of intuition also. Okay, so everything will be there. Whatever is required to learn machine learning, we will be having those things here. Okay, so I hope all of you are excited, and yes, I am also very excited. Great. Now, let me quickly introduce myself. Those who are watching first time. So let me just introduce myself, and then we will move to the course. So I'm Sachin Mittal. I'm co-founder and instructor at goclasses. I have done my masters from IISc in 2017, in the year of 2017 to 2019. So at IISc, by the way, I have taken, I think, 6 to 7 courses, or around 7 courses related to machine learning. And let me just tell you, I have, oh, sorry, 6 courses, right? 6 courses related to machine learning. So let me just tell you one thing, that at IISc, just one course is too heavy. For example, if you take, let's suppose, one course of, let's suppose, linear algebra at IISc, then this course, just one course itself, is very much heavy. And I've taken 6 courses related to mathematics or machine learning, which means either directly they're related to machine learning, or they're related to mathematics. I have achieved All India rank 33 back then in 2017, and I've also worked at Amazon as an applied scientist. So, applied scientist is one of the prestigious position at Amazon, and most of the time they offer this position to only MTech people, and that too from Tier 1 colleges like ISC, IIT Bombay, ISI Kolkata, CMI, IIT Madras, IIT Delhi, Kanpur, like that, right? So, they offer this particular position to only people who have graduated from top college, and that also to after very much screening, I can say. So this was one of the actually my dream, and I prepared for Amazon applied scientist, and eventually I got it. So I'm just sharing this thing, that I have worked at Amazon as an applied scientist. So why this particular mention was there, because at Amazon, this role is heavily focused on machine learning, not just related to, I mean, they ask machine learning things in the interview, but during Amazon I have worked at couple of projects, and all of the projects was heavily focused on machine learning. So so at ISC also I have worked at real data sets, like, I mean, there were real data sets at ISC where I work at, and at Amazon also I work at real world data set, right? Obviously at Amazon data sets. So okay, I will talk about my work at Amazon, that how that was related to machine learning, and how those projects were being implemented basically using machine learning algorithms. So I will talk about this particular I can say the task of things that I did at Amazon later on, because then only you will be able to understand that what is the problem statement, how we can solve this problem. So once you know few of the machine learning algorithms, then after that I will talk about my Amazon experience during the whole tenure that I worked at Amazon. Okay, so this is about me. Now, as you know that this particular course is going to be for machine learning course, so let's just first see that what is there as per Gate DA syllabus. Okay, so as a I can say as a mandatory slide. So this is here, that let's just first see that what is there in Gate DA. So this syllabus I have taken from official website, and they have mentioned couple of the machine learning algorithms in their syllabus. So, for example, they mentioned something like that, classification regression, simple linear regression, multiple linear regression, a couple of other algorithms they mentioned. Obviously, we will be studying all of these machine learning algorithms in very good detail, with very good intuition, with very good visualization, with very good mathematics, and whatnot. So, whatever is required to understand all of these algorithms, we will be having in this particular series. By the way, this is kind of the first course, you can say, that I'm teaching at Go classes, which is of my specialization. In the sense that I did my masters in machine learning, I work at machine learning, so I can I can say this is a course which is particularly very close to my heart. The reason is very obvious, because I have worked as a machine learning engineer, or as an applied scientist, or I have also worked at Xerox Labs. So I can say at Xerox Lab, as a research scientist, I work at Xerox Labs. So all of my previous works that I have done, either at ISC or in companies in the industry, I have done related to machine learning. So this is the very first course I can say is heavily aligned with my expertise that I have did in my masters or in the industry. So that's why this particular course is very much close to my heart, and I'm too excited to teach this course just like you guys. Okay. So these are the couple of algorithms that we will be studying in GATE DA syllabus. Now, as you see this particular syllabus, you will be finding, obviously, we will be studying every of this algorithm in very good detail. But those who know little bit about the syllabus or little bit about these algorithms, you will be finding that this syllabus is too much exhaustive, in the sense that if you know this much syllabus, right, then you just don't know the basics of machine learning. You actually know the many things about the machine learning. You will get the real feel of machine learning if you know these many algorithms. Let me tell you that how time has changed. Okay. So when I was at ISC, obviously now also it happens, but eventually it will change actually because of gate DA. So when I was at ISC, these all of these algorithms were there in my syllabus. So I can say I have taken machine learning course. There was a course, that course name was itself machine learning course. There was a course, that course name was practical data science course, PDS, practical data science. So if I just talk about these two courses, so I can say that this syllabus, the complete syllabus, were actually taught in these two courses at ISC. In second semester, I have taken these two courses in second semester, and this whole syllabus, obviously little bit more, maybe here and there little bit more. For example, in ML course, we used to study little more algorithms, just 2 3 more algorithms probably. Here also in practical data science, which we call PDS at ISC, here also we used to study little more. But but overall I can say that this whole syllabus is actually ISC 2 semester syllabus, oh sorry, 2 courses syllabus. Okay. So this means this whole syllabus is exhaustive. Now also at ISC, they offer these courses, as per best of my knowledge, they offer these courses, but eventually these courses are going to be upgraded at not just ISC, also at different IITs. Because suppose if you know all of this from GATE DA, right, then they will obviously not be repeating the things at ISC or any other top IIT. They will be having advanced algorithms in these courses. So obviously eventually I can say in just 2 3 years or 4 years they are going to upgrade these courses, just like they have upgraded their gate computer science, computer science related courses. For example, in operating systems, if you take operating system at ISC, they want to be teaching gate related things. Similarly, if you take ML course at ISC, if you take, let's suppose, after 3 years or 4 years ML course at ISC, they might not be, okay, this is just my strong intuition, that they might not be teaching all of these algorithms. Currently, actually, if you see ISC or IIT Bombay or any other IIT machine learning course syllabus, they will be having almost the same syllabus as GATE DA. And this will obviously not be changing just in 1 year. This will take 2 3 years or 4 years, because they have to be very much confident that students who are getting into the course, they actually know the things, right? Then only they will upgrade, otherwise they will keep on teaching. Understood my point? So this syllabus, have you understood the importance of the syllabus? This syllabus is actually pretty much exhaustive syllabus, in the sense that you will not be basically, you will not be saying, after studying this much, you will not be saying that you just know the basics of machine learning. You actually know pretty much, or you can say too much of the things. Okay. This is a very good syllabus, I can say, overall. Also, let me just I actually shared this thing in one of the session, but let me just tell you one more time, that even if you appear, let's suppose you appear in any interview, right? Suppose you are appearing in any fresher level interview, okay, at industry. Even if you appear in any machine learning interview, fresher level, obviously, right? Not like experience level interview. So if I say that, okay, um, as a fresher ML engineer, okay, if you, let's suppose, appear for some interview, right? then more or less they will be asking the same thing from this. Whatever we are going to study, they will be asking the same thing. So they will be asking this the things from this syllabus only. So this syllabus is pretty much exhaustive to crack any fresher level interview, I can say. Okay. So this syllabus covers covers all things required to crack any fresher level ML interview. Okay. I don't want to go into the detail that how much the company can offer or something, but I think as a fresher level machine learning engineer, they should be offering a good amount. If the company is really working in machine learning, they should be paying a good amount, in the sense they should be paying in the range of 10 to 15. Okay, I don't want to get into this, but based on my intuition, they should be paying this much. So this syllabus get you ready for this particular package for sure. Okay. Yes, there might be little more things, maybe little more algorithms that you need to do. For example, you need to understand, the basics of searching, sorting. I mean, the algorithm syllabus that you have, right, at Gate D also. So little bit of greedy algorithms are like that, right? Sorting algorithm, merge sort, quick sort. Little bit of coding is needed. Definitely, little bit of Python might also be needed. So whatever is there in the Gate DA, okay, along with the machine learning, this machine learning will be heavily weighted at the interview, but they might also expect you to know little bit of the algorithms, little bit of the data structures, like that, right? Definitely. So this syllabus is actually well designed syllabus. This syllabus is pretty much exhaustive syllabus. Okay. So just trust this syllabus, and once you know all of this, you actually know many of the things in machine learning. You are all set to, you can say, this is a kick start in machine learning. You are all set to crack any interview. You are all set to work full time in machine learning, or you are all set to understand machine learning or explore machine learning at the deeper level once you know all of this. Okay, this is very good syllabus. Actually, when this syllabus was released, this was released just last year. So I was very happy to see that. Okay, they have actually. I was actually thinking that they might be just having two, three at most linear regression, logistic, and at most this support vector machine (SVM), two, three algorithms. But actually, they have almost all the things that is required for any machine learning engineer. So that's why I was very happy to see this syllabus. So this syllabus is pretty much exhaustive. It covers many of the things in machine learning. Okay. Now, having said this, let me just tell you that what was the weightage of of this particular subject in Gate DA last year. So in last year, if you talk about last year Gate DA, then this particular subject, although this is very vast subject, or this is very important subject for Gate DA, but it doesn't mean that this is the only subject. Okay, this particular subject actually. Like I don't know, you will be happy about it or you will be sad about it, but it was just having the similar kind of weightage that, let's suppose, linear algebra has, or let's suppose probability has. Okay, so this subject was having 1 mark, 5 1 mark questions and 5 2 mark questions. So 5 1 mark plus 5 2 mark questions. So total you can say 10 questions were there from this subject, which was worth 15 marks, right? And I think the similar weightage was there for linear algebra, for probability. So you should not treat this. See, the ultimate aim is to crack Gate D, right? So you should not treat this particular subject as just only subject. This is my, this is my appeal to all of you, because you should not be just focusing on one subject and thinking that you can crack Gate D. In fact, the reverse may happen. Okay, like, which means that even if you do not focus on this particular subject, then it means you have 85 marks in your hand, right? 85 marks, even if you don't study this machine learning. So out of 85, if you, let's suppose, get 60 plus, or maybe let's suppose say 65 plus or 70 plus, right, then you are going to get into top IIT. So the other way around is true, that even if you don't study this subject, then also you can get into top IIT. So is this thing clear, that this subject alone can get you crack Gate DA, or this subject alone can get you admitted to top IIT or ISC, right? Okay. So this is important thing to note. But at the same time, since it is having heavy weightage and also this is interesting subject, so you can pay little more attention to this subject compared to maybe. I mean, I don't want to say this, but let's suppose if you're finding interest in this subject, then you probably can put little more attention to the subject. Okay. But the weightage wise, it is not having too much of the weightage, right? Okay. Now, coming to the prerequisite of this course. So basically, for this course, you will be knowing, I mean, you should be knowing actually little bit definition of the function. So what is a function? That it takes one parameter, for example, x square, and it gives some output, right? And similarly, at the same time, you should be knowing the what is a multivariate function. For example, it takes, let's suppose, two parameters, or maybe a vector. This xy is a vector. Maybe if you like to say x1, x2, right? Whatever. So then maybe it is giving a scalar as output, or maybe vector as output, or something. So this is called multivariate function. You should be knowing what is a matrix. You should be knowing what is a set, right? I mean, not much of the set or things, but yeah, like let's suppose this is a set or something like that, right? So this basics of this, mathematics should be okay to every one of you. Uh, if you don't know this, then you can ask me in between. That's fine. But I'm expecting you to know this, right? Don't worry. Definitely, we will be covering in between. And also, we have already covered all of this in our previous courses. For example, I've taken calculus where I've covered multivariate functions like this. I have taken, for example, linear algebra where I've covered obviously all about the matrices, right? Set is just a notation of the set. It is not much. You should also be doing probability, but I have not mentioned it because suppose you don't know much of the probability, then also you can manage with the course. That's why I'm not mentioned it very much explicitly. Okay. I mean, you should be actually knowing, but suppose you don't know too much, then also it is fine. To be honest, to be honest, it is better to know probability, linear algebra, and calculus, but not mandatory, right? So, see, the difference between better and mandatory should be clear. That if you know this probability, linear algebra, calculus, you will be understanding the things little more clearly. But if you don't know this, then it's okay. I will tell you the lecture number if the topic is needed. Okay. For example, let's suppose if I'm teaching linear regression, and let's suppose I feel that a multivariate function definition should be known to you guys. Then I will be just mentioning that okay, you should watch multivariate function from the calculus, and this is the lecture number, something like that, right? So I will mention in between. So that's why I'm saying that it is not mandatory. You can directly continue with the machine learning, but I'm not saying that you will be understanding all the things. If you know, it is better actually. If you don't know, then it's okay. I will tell you in the between. Okay. So one of the student is asking, I have completed linear algebra module 1, calculus module 1, and probability start with the random variable. Yes, that's great. So if you have completed module once, that's cool, not an issue. Okay, you can continue with the machine learning. So even if you don't know any of this, then also you can continue, but it is better to know this, right? Okay. Now, let's just get started with the definition of machine learning, that what is a machine learning. So today we will be just touching the basics, that what is a machine learning in a layman terms. You should be getting the feel of machine learning, that you might have been hearing about the machine learning. So before even I discuss about the definition of the machine learning or what is a machine learning, let me ask you guys, how many of you know what is a machine learning? Okay, maybe some of you know, and you don't need to explain it. Let me ask the reverse question, or let me ask the otherwise question, that how many of you have just heard about the name machine learning and don't know what is a machine learning? How many of you have just heard about this name machine learning and just excited to learn machine learning along with me? Okay, so Ajay is saying that he had just heard about the machine learning. Arjun is saying he had just heard about the machine learning. Sujit, Avnab, and many, many, many people are saying they have just heard about the machine learning. So that's great. I mean, that's really good that if you have, even if you have just heard about the machine learning, it is fine, right? So there are many people. Okay. So it is really good to see that good number of students have joined today. So current number is 78, which is really good. Actually, people prefer to watch lectures offline, which means that later on they prefer to watch the lectures once the live lecture is over. So it is up to you. I mean, I'm not saying that you should only be watching the lectures now. You can watch the lectures later also. But if you watch in the live, then you can discuss with me. You can express your concerns. It is better. But otherwise, also it is okay, right? Cool. Now, let's just get started with the basic definition of machine learning. That what is the machine learning in layman terms? Okay. So just think like one thing, that suppose you are someone who wants to, design something. Okay. I mean, you who wants to innovate something. I mean, I want you to think as a researcher perspective, or as a, as something who is, very curious to develop something. So just take the inspiration from humans. Okay. That how human learn. So we learn from our past experience, right? So for example, human can learn from the past experience. For example, like this. Suppose this is you, or this is me, or this is any other human being, and if we ask that particular person that what is this object, then this particular person will think, right, that okay, I have seen this object somewhere, or maybe similar kind of object somewhere. For example, okay, I have seen something like this was car, something like this was car, something like two wheeler was bike, something like this two wheeler was also bike. So I've seen this kind of object somewhere, and he will try to recall. Obviously, like now you have too much of experience in the daily to daily life, then you don't need to recall it. I mean, with the focus, but at the back end, obviously your mind is getting recalled, right? So you just think about it. Suppose he's just a baby, in the sense that let's suppose he's just a 5 to 6 year old, or maybe a little lesser also. And if we are showing this particular baby first time that what is this object, and then maybe the couple of examples we have already shown to him, let's suppose, then will not be recalling that okay, this was, I think, car, okay, something like this is car, isn't it? What I want you to focus on this particular slide is that doesn't how this human mind work. What do you think? Right? Isn't this human I mean isn't like this human mind work? Yes, right. So basically you will try to recall from your past experience, and then you will say it is a car. Okay. It should be clear to everyone. Now you might be saying that okay, no, I don't do it by just looking at the car, I just say it is a car. Obviously you don't do it, right? I mean, it is just the fraction of millisecond the computation is happening, so that you are not realizing that at the back end you are actually processing it is a car, isn't it? So you recall that okay, based on your past experience it is a car, right? So that's how human mind work. I hope that is clear to everyone, that that's how human mind work. For example, let's suppose I show this particular object, right, to this is a fictional character, by the way, Tarzan. Has anyone seen this movie? It was, I think, 90s movie. Uh, in America, that was a 90s movie. Has anyone seen this movie? Okay. It's not required for this particular course to see the movie, but I'm just saying, let's suppose he is someone who is actually, I think, in that movie he was, being born and brought up by animals itself, right? Apes or monkeys, something like that. So he was no, that Tarzan is different. Tarzan Wonderful Car is different. Okay. This Tarzan movie is different. This is movie was in America, and in 90s. I don't remember the exact year, but yeah. Okay. Anyway, so consider a person who has always been in a jungle, right? Yes, it was like a Jungle Book or a Mowgli, right? So consider a person who was always in the jungle, and who was, born and brought up in a jungle, and who have never even seen the humans, but somehow he is human. Okay, Mowgli, if you have seen, that's okay. Otherwise, that's fine. Even if you have not seen, suppose I show this particular object, or the car to this particular person. What do you think that this person will reply? What do you think? Obviously, let's just call him Tarzan, because his name is Tarzan. Okay, so Tarzan, what do you think this Tarzan will reply? Tarzan will say that, okay, I'm okay. Andrew Tapi, okay, you just change your name. I'm sure that it's okay. Andrej, okay, sorry. Steel Riano, Steel Wala Riano. Okay. So he's saying Steel Wala Riano. Great. So basically, if we show this particular object to Tarzan, then probably he will not recognize this, right? He will say that, okay, I don't know, right? Because he will just try to recall from his past experience, and in his past experience only animals, giraffes, or any kind of sorry, elephant, giraffes, or such kind of animals are there. Can you see this particular image? Okay, it is little smaller in size, but yeah, I hope you can see this, right? So basically, in his past experience, it was just like this. So we'll try to recall from his past experience, and it will say that, okay, I have not seen something like this, right? So he will not be able to classify, or he will not be able to recognize this object. He will say that I don't know what is this, right? So, but at the end of the day, Tarzan was human, right? So I'm assuming that human being can observe and then they can learn. Okay. Now tell me, can we ask him to learn this? Can we make him learn? Because he's a human and we are very proud of human, right? So we can make him learn somehow. Let's just make him learn, right? So let's just show him some objects. For example, I show him this object, this object, this object, and I tell also, not just show, I will just also tell the label, or will also tell that what kind of object this is. For example, I will show this object and say, see, this is a car, this is a car, this kind of things are car, this kind of things are bike. Let's suppose this is just a for example, but suppose I tell him, 100 times different type of cars, different type of bikes. Don't you think he is smart enough to understand that, okay, next time I give him, then what will he do? Next time I give him this particular object, what will he do? He will say he will say oh, from my past experience, I just don't only know the animals, I also know these kind of objects. So he will say, oh, see, this is a car, right? Isn't it? He will say it is a car. Why? Why? Because of his past experience. He will try to recall from the past experience. And if the past experience contains those kind of objects, he will say, oh, now I know this is a car, isn't it? So what we just did, we just, trained someone, right? Isn't it? We just trained someone. He happened to be human, but our task of this particular course is to train machines just like human, isn't it? By the way, this is a famous quote from Alan Turing. Alan Turing has been the greatest ever scientist in computer science. You might have heard about the Turing Award. Have you heard about Turing Award? It is the prestigious award in computer science. Okay, there is no award above than Turing Award. So Alan Turing was the greatest scientist ever in computer science, and he said that what we actually want is a machine that can learn from experience, right? Okay. So yeah, there was a movie on him, The Imitation Game. Great. So this is a famous quote from Alan Turing. So what he said that we train human, that's fine, but we basically want machines to train just like we train this human, right? Understood? So this is the goal of this particular course, that we want machines to train just like we have trained this particular human being. Great. Now, let's just build the basics and let's just see how we can train machine, isn't it? So now let's just see. So Pankaj is saying, can machine think? We will force them to think. Okay. This course will force them to think. Don't worry. So let's just see how we can train machines just like we trained Rajan, right? So let's just start with a very, motivating example, or very simple example, or I can say a very toy example. Let's just start with a very toy example. Let's just consider this example a toy example to get started with the machine learning. This is the example that I particularly framed, uh, in the sense that I have not find that example anywhere. This is just my innovation that I just framed this example. I thought that this could be a good example to get started. Suppose there are two pairs x and y. Okay, let's just assume there are two pairs x and y. X is 1, y is 2. Okay, let's suppose that I give you some numbers. I say if x is 1, right? If x is 1, then I'm telling you, I'm giving you these whole numbers, and I'm telling you if x is 1, then y is 2. Okay. The second thing I'm saying, if x is 2, then y is 4, like that, right? Suppose I'm giving you some numbers like this. If x is 3, then y is 6. If x is 4, then y is 8. Okay. Are these numbers fine to everyone? Okay, great. Now let me just ask you a simple question. Suppose I give you this. Okay, this is given to you. This is given to you. And then I ask you that if x is 5, then what is y? Sorry. Then can anyone tell me? Great. So you have seen that, okay, if x is 1, then y is 2, then 2 and then 4, I think it is double double. Oh, great. If x is 5, then y is 10. If x is 6, right? So you will say that, okay, if x is 5, then y is 10. If x is 6, then y is 12. If x is 7, then y is 14, right? So you will give these as an answers to me, isn't it? Aren't you capable of giving these answers? I think you are capable enough to give these answers, and I think almost all of you have given these answers, right? So 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 I can say that these answers are given by you, right? Great. Let me just congratulate you, because you have just applied machine learning. Okay, even you didn't know that what you did, but you actually applied machine learning, which means yes. So Ashutosh is saying that you just applied machine learning on us. Yes. So basically, you applied the machine learning, which means what you actually did. Let's just break it down in steps, right? So what you actually did, you have seen this data. That was the step one. Then what you did after seeing the data? Can anyone tell me what was the step two? What was the step two? You have just analyzed the pattern, right? Yes. So you saw the data, you analyze the pattern. Or in other words, if I can use that word, so basically you saw the relationship between x and y, or you show that how x and y are related, or what function they are related. You figured out that, okay, they are related using, if I say that, okay, if y is a function of x, then you figured out that they are related using 2x, right? So just a second. So given this, what you actually did, right? This was the step one. Now you yourself did it, right? What you did. This is what you did. Remember, okay? You did figure out relationship between x and y, isn't it? And what was the relationship that you have found out? You find out that, okay, y is actually, if it is a function of x, then it is actually 2x, isn't it? Now what was the next step that we performed? The next step was that I have given you some unknown data. For example, I mean unknown data in the sense that where x is known but y is not known. For example, I have given you the data where x is known and y is not known. right? So this data we will come to the terminologies later on in the tomorrow lecture. Today I just want to build some intuition of machine learning. But yeah, this data is called unknown data. In a technical term, can anyone tell me what is this data which we call it test data, right? Test data. We call this train data. Okay. So what you did, you have seen this. Now remember, this is what you did, right? You did figure out that okay, y equal to actually 2x. And now, given the test data, now since you know, okay, you know that this function or the relationship between x and y is actually 2x. This is what you figured out. And then I gave you as a test, okay, or as a new sample, I gave you 5. And then you told, see, I know the relationship between x and y, which is 2x, then this is 10, right? This is what you did. Then I asked you, okay, can you also tell me about 6? Then you told, yeah, I can tell. And then I asked you that what is this number? You will say it is 12. Then I ask you, can you tell me about 7? You say that, okay, yeah, I know about 7 also, which is 14, isn't it? Is this okay to everyone that what we did, right? So once we understand that what as a human we did, we will try to mimic it. I mean, we will try machines to mimic it, which means we will try to develop something that machine can do. So basically, in simple words, what we are aiming for machines to do, to analyze the relationship between x and y, isn't it? In simple words, I can say that my aim for machine is to analyze this function, the relationship between x and y. Okay. Once the machine analyzes that, okay, this is the relationship between x and y, then machine can give me the output. Given the inputs, machine can give me the output. I hope that is fine to everyone, right? So remember, this is what you did, but this is what we want from machine to do. Is the idea clear to everyone? Okay. So I will say, for example, I will say that my input to the machine is some pairs of x and y. Okay, some pairs of x and y. This is my input to the machine. And then let's suppose I'm also telling machine that the relationship by and x in relationship between by and x is something like this. Okay, something like this. But here a and b are unknown. Actually, I don't know what is the relationship, so I will say to machine that a and b are unknown. I mean, the relationship I will say, for example, okay, this is just one example. The relationship I will say that linear is a linear relationship. I will feed them pair of x and y, and what I'm expecting from machine, what I'm expecting from machine to give me. Yes. So I'm expecting from machine to give me a and y, right? Expecting a and b, right? So this is one kind of machine learning which is called supervised machine learning. But let's not get into that classification. I will tell you that what is a class. I mean, what are the type of machine learning algorithms. But yeah, this is the, I can say, the majority of the machine learning algorithm falls in, which means we will tell them that okay, there is a relationship between y and x. Probably, okay, based on my intuition, probably the relationship is linear. For example, it could be x plus b. Or for example, if I'm very much intuitive, or I'm thinking that okay, it is not linear, it could be quadratic, then I can give, okay, I can say that, okay, probably the relationship is like this. Okay, that's also fine. I mean, let's not get into this. I basically what I mean to say that I will give some relationship, okay, and I will expect the parameters. Okay, so parameter finding and machine learning is same, which means we ultimately want to find the parameter. If we know the parameter, we know the relationship, and we can conquer this world. Now you might be wondering that how we can conquer the world, right? Just using the parameters. Let me just tell you one simple example. that how you can change few of the things. For example, there are many obviously applications of machine learning, but as a as a start, let me just give you a very simple but very effective example. For example, let's suppose let's suppose you have a data of house prices, right? Suppose you have data of house prices. For example, there's a house one, right? Now let's suppose this in this house the square feet, okay, I can say that's built-in area or whatever, right? Built-in area, and there are many I can say features of this house. Built-in area, number of washrooms, you know number of bedrooms, like that, right? There are many features, there could be many features, and at the last I'm having some y, which is price. Okay, at the last I'm having some y, which is price. Let's suppose if the built-in area, I'm just obviously year built, in which year it was built, there are many things, in which area it is, there are many things, but I'm just keeping just a few parameters. Let's suppose the built-in area is, let's suppose, some 2000, something like that, right? Okay, I'm not worried about the unit, it could be anything, but let's just keep it 2000. Number of washrooms, let's suppose 3. Number of bedrooms, let's suppose 4, or like that, right? Let's suppose the price of this is okay, anything, okay, let's suppose uh, okay, 2 crore. Okay, I don't know. Okay, it will depend on obviously in which area it is, like that, right? But let's suppose there's a house 2, right? The house 2 is having, let's suppose, 1900 built-in area. Maybe it is having 4, this is having 3, let's suppose. This price is, let's suppose, 1.5 cr, and so on, right? And so on. Okay. Now now let's suppose there is one more house, or maybe let's suppose you have this data set. Now there is some person, okay, this that comes to you, this is the data set with you. There is some person that comes to you. He will say that, see, i have I have one house with me which is having this much features. Okay, he will come up with a new house to you. He will say that, okay, this my area is 1875. Let's suppose this is 3, this is 4, or something like that, right? Or maybe there are many parameters. I'm not showing year built, in which year. Okay, year built, let's suppose it has been built in 2005, it has been built in 2015, year built, right? So there are many features. Let's suppose it is 2020, right? Suppose something like this. Now he just asking to you that, can you tell me what is the price, what is the best price for me? Now, what you will do, you will say that, okay, for now it is seeming like a little complex problem, but later on you will understand that it is easy to solve using machine learning. What you will do, can anyone tell me? You will basically, okay, as a human, you will figure out, okay, 2000, it was 2000 बिल्ट इन एरिया था, तो 2 करोड़ का बिका, लेकिन हाँ, बट वो पुराना था यार, है ना, ये तो काफी नया है। शायद 2.5 करोड़ कुछ ऐसा हो, है ना, बट यार ये कम है ना, एरिया कम है, तो चलो 2.3 में बिक जाएगा, या कुछ ऐसा। मतलब यू विल डू ऑल सॉर्ट ऑफ दैट कैलकुलेशन। वो मीम नहीं देखा, मतलब एकदम वो मैथमेटिक्स उड़ के आती है ना, वो देखा है किसी ने वीडियो? जो मैथमेटिक्स से सिंबल सिंबल एकदम उड़ के आते हैं, ठीक है? तो वो सब तुम्हारे दिमाग में जाएगा, और तुम फिर फाइनली बताओगे कि ओके, दिस इज 2.3 cr और समथिंग लाइक दैट, राइट? आई मीन, मतलब यू विल कम अप विद सम नंबर। ओके, वॉट एवर इज दैट नंबर इज। ओके। Piyush is saying we do it for RCB every year. Okay, great. So basically what you are doing, you are analyzing the data, right? Ultimately you are analyzing the data, isn't it? Okay, so Sumya is saying that but ये काली पुराना है, 5 5 करोड़ का बिकना चाहिए. Okay, anyway, you will come up with some number and you will analyze the data. But don't you think that as a human you can make mistakes? उस दिन क्या पता तुम्हारे सिर में दर्द हो रहा हो, राइट? या फिर तुम्हारा मन नहीं हो, या फिर आपकी ट्रेन हो और तुम्हें जल्दी हो किसी चीज की. Anything can happen, right? At that particular moment you might not be enjoying the weather, and that's why you are making the mistake. Or maybe you just had a fight with your wife, or with your girlfriend, or with your boyfriend, or with your husband, right? And then you are making the mistake. Or maybe for any random reason you can make the mistakes. So we can obviously not rely on the human, because this is something that we need to analyze. So if there's a data to analyze, why not to take the help from machines, right? Machines doesn't have emotions like this. ओके, वो वेदर को देख के रिजल्ट नहीं बताते. जो रिजल्ट है वो वही बताएंगे, राइट? आइदर यू डू इट ऑन द फ्राइडे और यू डू इट ऑन द संडे, दे विल टेल द सेम थिंग, isn't it? So basically we can take help from the machine. We will feed all of this data to the machine. This is called trained data, right? So we will train the machine that, see, okay, how we are going to train, because this is little seeming little complex. I will tell you about it. But yeah, the ultimate thing is that we will train the machine, okay, with this data, because we don't want human intervention, right? मतलब हम नहीं चाहते कि एक इंसान इसका जजमेंट ले, क्योंकि humans can make mistakes. ऑब्वियसली वी कैन क्रॉस वेरीफाई. मतलब ऐसा नहीं है कि इसने 2.3 करोड़ बोल दिया तो अब 2.3 में ही बिक जाएगा, या फिर 2.3 में ही बेचना है. हो सकता है कि इसके अगर मान लो कि 2.5 मिल रहे हैं किसी को, तो उसमें बेचेगा ना कोई भी, है ना? तो मतलब वी कैन क्रॉस वेरीफाई, दैट्स फाइन. बट वी विल टेक हेल्प फ्रॉम द मशीन, एंड बेस्ड ऑन द पास्ट एक्सपीरियंस, बेस्ड ऑन ऑल ऑफ द डेटा. दिस इज जस्ट फ्यू numbers. This is, let's suppose, 3 or 4 examples. But this could be 1 lakh house, right? 1 lakh's house. Is it even practical to analyze all of these houses by the human? Just one or a team of humans? I don't think so, right? So it is neither practical nor it is better, right? Nor it is good for a human to analyze the data. So to analyze the data, we will take help from machines. We will say that, okay, this is our X. We will feed this as a X. This is our Y. Based on this X and Y, this is the relationship. You learn the relationship. Okay. Whatever the relationship, you learn it. And given this new X, you tell me the Y. Isn't it? So this is called machine learning. Basically, we are asking machine, we are taking the help from machine to analyze the data and finally give me Y. Right? Okay. So there are few questions like how do we even find out whether it is a linear relationship or not? No, you cannot find out it. You need to just guess it, or maybe you can. I will talk about it. Okay, I will talk about these things. Don't worry. Okay. So there are few doubts. We can give an estimate based on the variables provided. Okay, Vamsi is asking, does machine learning develops the algorithm when we provide both input and the output as training data? Machine learning will give you the parameters. Okay, you will say that, okay, probably you will say to the machine, probably this. Let's suppose this is, I mean, in the X also, this is, let's suppose, X1, this is X2, this is X3, this is X4. So you will say to the machine that probably these are related like this. Okay, plus maybe some constant, maybe you probably these are related like this. Can you give me ABCDE? If you give me ABCDE, then I will give this price, right? Okay. So is the crust clear to everyone? Let's not get too much into it, because you will not be even able to understand whatever I explain. So it will just waste the time. Okay. So is the crust clear to everyone that what is our objective? Our objective is that we will ask machine to learn or to analyze the pattern to give me the final parameters, so that using that parameters I can finally predict, or I can finally tell that what is the Y. Why? Because humans can make mistakes, right? We don't want human to analyze the data, right? A large chunk of data. We don't prefer humans to by themselves. Okay, great. So, what is a machine learning? By the way, the slide I have taken from Stanford. So, what is a machine learning? The goal of the machine learning is to come up with a rule. Rule means like let's suppose this y and x are related like this. Okay. So it will come up with a and b using the training data, which is x and y, right? Now, if this is a test data, this is a test x, then it will give me the what is the y. So basically, we are looking for a and b only. This is the simplistic version of the machine learning, you can say. Okay, there could be the complex models. We will see later on. Okay, don't worry. Now let's just see more. So basically, in the programming, the traditional programming, you can say, is is there which takes some input, give the output, and that is done using some program. For example, okay, I think they've used I think C programming syntax. Actually, doesn't matter. But yeah, for example, if this is the input, this is the output, and then this algorithm is actually producing this output, right? So there is an algorithm, there is an input in the programming, there is an output, right? So the algorithm produces the output. But let's suppose if we talk about the machine learning, so basically in the traditional programming, there's a data, right? And we also give the programming to the or the program to the computer, and then it gives the output, right? So this is the traditional programming. But the machine learning, I mean, this picture might not be fitting exactly, but this is a quite popular picture, so that's why I've taken it just to compare between machine learning and the traditional programming. But in the machine learning, we have the data, which means this data is actually x. We have the output, which means what is the output y, and then we are expecting as a program. So basically, this is a little more accurate. So you can say you give x and y, and then you are expecting machine to give you the function parameters, right? This is the machine learning. Basically, you're looking for A and B only. Okay. So we will talk about machine learning, obviously in this particular course, and today we will just build more intuition. I mean, little bit intuition must be clear to everyone, but we will build more intuition using the mathematics itself. Okay. So don't worry. Today only we will build more intuitions. But before that, let me tell you that machine learning types. What are the types of the machine learning? and uh, and what are each of this? So basically, machine learning can be you can say, with the type of the methods, basically, or in other words, you can say with the type of data, what kind of data we have. If we have x and y pairs, right? If we have x and y pairs, based on the data, okay, based on the data, if we have x and y pairs, based on the data, we can classify machine learning into three parts, right? Based on the data, the type of data. There, I mean, there could be other type of classification also for the machine learning algorithms. For example, discriminative algorithms, generative algorithms, like that. But based on the data, it could be supervised, which it is like three most popular type of the classification. It could be supervised, it could be unsupervised, it could be reinforcement learning. This reinforcement learning, by the way, is I can say is very much specific, and only few people study it. Okay, only few people. Even if you are great machine learning engineer, you might not be knowing anything about the RL or reinforcement learning. So this reinforcement learning is not needed for gate DA, neither it is needed to crack any interview, nor it is needed for anything. Okay, I mean, in the sense that for most of the applications, yes, this is needed for few of the applications, which we will obviously not be worrying about, because it is not even in the gate syllabus. So you can say in other words, it is not in the gate syllabus, right? And what exactly it is, you don't actually have to know, because it is complex to even explain that what is the reinforcement learning. Okay. Now let's just see supervised and unsupervised algorithms. So supervised algorithms are those algorithms which have XY pairs, which means you have X and Y also. But here you don't have Y. Okay, you don't have labels. We don't have Y. Okay. Yeah, broadly they're classified supervised, unsupervised, and reinforcement learning. You can also have semi-supervised, which is a mix of this. But anyway, like for our gate DA, this much is too much. I mean, this much is very good enough. Okay, because that's only in the syllabus. Now, now, let's just talk about this supervised and unsupervised little bit more. That what is the supervised learning and what is the unsupervised learning. For example, for example, let's suppose I give few images to the machine, and along with the images, let's suppose I give the label, which means this is a cat, this is also cat, this is also cat, this is also cat, this is a dog, something like that, to the machine learning algorithm, right? Then this kind of setting is called, what do we call it? Supervised. Why it is supervised? Because we are giving, along with the image, which is X, we are giving the label, right? Which is a Y. So X is an image and Y is your label of the image, right? So that's why it is called supervised learning. For example, if you learn the relationship between X and Y, obviously some of you might be thinking that how we can feed the image or how we can represent the image as a, X or something like that. So we might talk about it. Actually, image is just a matrix, right? It is just a matrix. So this is just a data in the, this is just numbers. Okay, this is just matrix. So if you load this image using any, let's suppose, any Python library, okay, it will be in the numbers only, right? So it is a RGB image. It will be having some pixel values. Yes, OpenCV is one of the library, as you mentioned. Okay, as let's not talk about the libraries, but yeah, this is just one matrix, and this is the label corresponding to that matrix. Okay, so suppose if we train some machine learning algorithm, then then after that, if we don't give, okay, if we don't give, let's suppose if we don't give the label, okay, so here y is not there, okay, y is not present obviously in the test, because you don't know, right, what is this, right? Y is not present. Then we are expecting our algorithms or our model to predict that, okay, whether it is cat or dog, right, using the relationship that the machine has learned. So anyway, this is supervised learning. There are many other examples of the machine learning. In like, machine learning is heavily used in the speech recognition, right, in the face identification. For example, this is who, like, I mean, the person name of the person, this is whom. Maybe you might have seen this in the Instagram or any other social media platform, like, I don't know whether it is there in the LinkedIn or not, but over the Facebook, that is definitely there, that it detects that, okay, the person name, right? So that you can tag that person easily. So in the face identification, the machine learning is heavily used. In the autonomous driving and the many applications, right, the machine learning is being used. In the machine translation, I mean, if you want to convert English to, let's suppose, Hindi, okay, or English to French, or the language translation, any other language translation, so there are actually extremely, you can say, extremely many examples of machine learning, applications of machine learning. We can keep on going it. Okay. Okay. Now let's just talk about a simple problem that I want to formulate today, which is a ice cream sales prediction. Which means, suppose we are running an ice cream shop, and at any given day we have to stock up ice cream accurately. Which means suppose, or maybe not we. Let's suppose someone is running ice cream shop, right? There is some person who is running, let's suppose, ice cream shop. This is, oh, my drawing is very bad, by the way. Okay, so this is, let's suppose, his ice cream shop. Okay, now that person is running ice cream shop. Now that person comes to you for help. What kind of help that person need from you? Okay, he say that, see, I want to optimize something. And what is the optimization he's looking for? He will say that, see, I want to stock the ice creams such that at any given day it does not go out of stock. Okay, which means let's suppose tomorrow, okay, tomorrow is, let's suppose, or maybe let's suppose for today, if I say today the temperature is, let's suppose, 40 degree, which is quite high, right? So what do you think the ice cream sales will be? Less or more? more, right? So basically he's coming to you, he's saying, see, today seems to be very hot day, can you suggest me how many ice creams I should be selling today, right? So he's coming to you with the temperature, and what is your task, or what your machine learning algorithm should be doing, because you are a machine learning engineer, right? Remember, okay, so you are enrolled in the course, so you are a machine learning engineer, so you are expected to give some number, right? So you will say that, okay, if today is 40 degree, then okay, then probably you will sell maybe 200 ice creams. Okay. Then tomorrow, let's suppose he comes, he says that, see, today is even 45 degrees centigrade. You will say, oh, if today is 45 degrees centigrade, then probably you will be selling two 110 ice creams, right? Something like that, right? So basically, what I'm trying to say here is that you want to find out the relationship between temperature and the ice creams being sold. Can you always say, can you see the inherent problem with this particular objective function, or the formulation is that you cannot always say that, okay, 500, can you always say 500? Will it be safe? Do you think 500 is a safe number? Most probably, actually 500 is just safe in the sense that, if I be very practical, then maybe it is almost impossible to sell 500,000 500 ice cream. Okay, you are saying that it is not a good number. Why it is not a good number? Yes, so Anurag has given the correct answer, because it is overstock, right? So 500 is okay in the sense that he will never go out of stock, but don't you think that it is too much? So I should not be suggesting some number which is too high. Can I always suggest 50, or can I always suggest 40? Can I always suggest 40? No. I should not be suggesting any number which is too low, because otherwise that person will be out of stock, right? He will not be earning good enough in that entire day. I should not be telling too much, because the person will stock it, and if it doesn't get sell, then maybe let's assume that ice cream get get spoiled in just one day. Okay, so it is not usable after one day. Let's suppose. So I cannot tell too low. I cannot tell too high. Right. I should be giving him some good number. So for example, he comes to me and he also tell me the data. He just tell me these 2 days data. He says that yesterday, or maybe day before yesterday, was 25 degrees centigrade, and the ice cream sold by me was 108. And if it was 28 degrees centigrade, then ice cream sold by me was over 120. He is just telling me 2 days data. My job is to give him, and then he comes with me that 2 days 30 degrees centigrade. Can you tell me? My job is to give him this number. Is the problem clear to everyone? That what we are trying to solve here. See, he is giving me this data. Okay. This data, we technically call it, can anyone tell me? We call it train data. We will have the technical terms later on. The terminology will be get clear later on. But yeah, let's suppose he's giving me some data, and then later on he's also, he's very clever. He's also coming up with the test data. He's saying that, okay, now can you tell me how many ice creams I will be selling this today? Because today seems to be 30 degrees centigrade. Okay. So let's just see how we can help him. Do you want to help him as a machine learning engineer? Yes. So I think we can help him using our machine learning expertise. Let's just see. Okay. Okay. Sorry. This is not the question. Great. So let's just try to help him. Right. What you will do, you will say that, let me just do one thing. Let's just have y, which is this, and maybe this y and x are related like ax plus b. Okay. Ax plus b. Maybe this y and x are related like this. Then I will say that, okay, that's why this y is 108. Okay. This y is 108. This should be equal to, a is unknown here, x is 25,
Again, this b is unknown. Similarly, you can say that this 120, this is equal to a is unknown here, 28 plus b, right? Okay. So these are the two equations, two unknown, and then you can solve for a and b. To be honest, you don't need machine learning here, right? Do you need machine learning here? Or you just need simple, problem solving two equations, two unknown, or maybe linear algebra? Honestly, you don't need machine learning here, right? That's fine. That's fine. That's okay. Okay, don't get disappointed that we are not applying machine learning. Okay, we will be applying, right? Don't worry. So honestly, you don't need machine learning. You can solve for A and B. Can anyone tell me what is the answer that you're getting for A and B? I think A is 4, right? This is 3A equal to 12. Okay. So your A is 4 and B will be 8. Okay. Because this is 100 and then, okay, B is 8. Right. So basically, this is how you are solving. Or maybe if you are too techy in the linear algebra, then you might prefer to do using the coefficient matrix, something like this, right? You may say that, okay, this is 25, this is 28, this is 1 and then 1, this is A and then this is B, this is equal to 108 and 120. I mean, if you're very stubborn, or if you prefer to apply, linear algebra kind of, syntax or the matrices, then you can do it. If you have not studied linear algebra, then don't worry. I mean, this is something called system of linear equation, and using which we find out these, this vector, non-vector, which is x1, x2, a or b or whatever, right? Okay. So basically, a and b are this. Now, if he is coming up with 30-degree, then what will I say? I will say that I know with what relationship you are actually selling out your ice creams. So y equal to, maybe I will say a value is 4, right? 4x plus 8. So I will say this is your number. So if you are coming up with me with 30, then if I feed 30 here in this, algorithm, or in this particular machine learning algorithm, then it will be 4 into 30 plus 8, which will be 128, right? Is this fine to everyone? That how we have helped him? Okay. Probably here directly we have not applied machine learning, but that's fine. I mean, you can also apply machine learning, but let's just see that how the things can be more complex, and how we and why we even need to go beyond the linear algebra, right? So this was the linear algebra point of view. We were easily able to solve this particular problem, but we need to go beyond linear algebra, right? So let's just see this, right? So now let's see some example where we need to go beyond linear algebra. Okay. So someone is asking how we got the function ax plus b. This was actually our assumption that both are related by some function, some linear function. This is a basic assumption that we did, right? This was our assumption that both are this x and y is following some linear relationship, which is ax plus b. Okay. To get started, let's just start with the linear relationship or the linear regression. Later on, we will move to the more complex algorithms. Okay. Great. Now let's see another problem, and let's just try to see if that can also be solved using linear algebra. So basically, the problem is same. Uh, he is giving you some data of the ice cream sales. For example, he's saying that 25-degree is the temperature, then 108 is the number of ice creams he's selling. If 28 degrees is the temperature, then 120 is the number of ice creams he's selling. If 31-degree is the temperature, then 132 is the number of ice cream he's selling. Right? Okay. By the way, this, if this is the only data we have, let's suppose 25 and 28. If this is the only data we have, then I think we have come up with the solution. What was the solution? Using this data only, I think we have come up with the solution, and the solution was y equal to 4x plus 8, I think, right? Okay. Now we have more data, and we see that this data unfortunately is not following this pattern, in the sense that now this y is not following this, right? If you multiply 31 into 4, what is 31 into 4? This is 4, 124 plus 8. This will be 132, right? Okay, sorry, this is following, right? Okay. Here, yeah. Okay. Is there anything wrong I did? This is 132, right? Okay, great. So here it is following. That's fine. But let's suppose he's coming up with some data where it is not getting followed. For example, what I mean to say that this particular data does not, I mean, all of these 3 points does not lie on the single line. Okay. For example, let's suppose, let's suppose he's giving me early, now currently it is 132, but let's suppose it is 140. Okay, suppose, assume. Okay, suppose this is 140 instead of 132. Let's suppose this is 140. Now let's just see what we will be doing. I mean, if it is 132, then we are very much happy, but with 140 the things might be very much different. Okay. Now suppose this is 140, and my question, my task is to solve the problem such that I want to predict the ice cream sale price, right? Ice cream number of ice cream that are being sold in that particular day. So if I apply, the linear relationship using these two only, it was y equal to 4x plus 8, right? But unfortunately, this particular point does not lie on the same line, which means if I do 4x plus 8, this is 132, right? This point does not lie on this line. This point is actually 140. What does this mean? See, let me just tell you that what is happening here. What we will do, let's suppose we don't even know that we have solved this problem before, right? What we will do, we will take this problem, we will assume that, okay, let's suppose this y and x are following some linear relationship. So y equal to ax plus b. This is the linear relationship that it is following. So here, this 25 equal to a is unknown, sorry, 108 equal to a is unknown, this is 25, plus b is also unknown. 120 is equal to a is unknown, this is 28, b is also unknown. 140 equal to a is unknown, this is 31, plus b is also unknown. I will write three equations and I will try to solve them. See, if it is 132, then also I will do it. Okay. If it is 140, then also I will try it. Is this fine to everyone? Now, if you try this, then you will realize that it is an inconsistent system, in the sense that using these three equations, you will not be able to find A and B. Okay. It is there is no solution exist that satisfy all of this line, all of this these equations. In the sense that if you are little bit familiar about the linear algebra, then you can try solving it. You will be having, 25, 28, 31, 111, right? You will be having this, you will be having a and b, that is equal to 108, 120 and 140, right? Now you can try solving it definitely. For example, you can subtract this 31 from this 25 or vice versa. Then you will be having this, let's suppose 25 1, or maybe let me just try solving it. Are all of you convinced that this is an inconsistent system? Okay. So basically, you can do it. This is 25 1. This will be 30. This will be 60, right? Sorry. This is 108. And then you can subtract this from this. So this will be 12 and this will be 32. Right? So you will realize eventually that this is not solvable. Okay. So this is an inconsistent system. Okay, using these two lines, maybe you can figure out that okay, this is saying 30. It should be if it is 6, then it should be 24, right? Then only it is consistent, right? Otherwise it is inconsistent. So basically, using linear algebra, you are not able to solve it, right? That is why we need to go beyond linear algebra. I mean, linear algebra is very powerful. This is a little wrong to say that okay, using linear algebra you can't solve it. You can somehow do something, okay? But let's not worry about those things. We will come to those things later on. But for now, let's just in the layman terms, I can say the linear algebra, or at least the system of linear equations can't solve it, right? Understood? Now let's just go back to the previous problem of something that we have motivated the things. So what was the very first mathematical example that I have shown you in the machine learning? The xy pairs, right? So let's just go back to our xy pairs, right? Go back to the which was xy pairs, right? Now suppose you have those xy pairs. Now this time these xy pairs are not very simple. Suppose these xy pairs are like this. If this is 1, this is 2, this is 3, this is 4. Okay. Then corresponding to 1, let's suppose you have 2. Corresponding to, you have instead of 4, you have, let's suppose, 4.1. Corresponding to 3, instead of 6, let's suppose you have 5.7. Okay. Corresponding to 4, instead of 8, let's suppose you have 8.4. Something like this, right? Okay. Now corresponding to 5, can you tell me? Corresponding to 5, can you tell me? Is this so easy? Okay. Seems like it is a difficult problem, right? It is definitely a difficult problem, right? So corresponding to 5, how to figure out that what is there corresponding to 5, isn't it? Because there seems to be not very obvious relationship, or there seems to be even, you can say, the relationship is not the exact linear, in the sense that it might not be even following ax plus b. Okay. So the ice cream problem that I've shown you, actually there were 3 points. Okay, three data points, right? These 3 data points are actually not collinear, in the sense that these 3 data points do exist on different lines. So basically on 2 lines. Obviously, I mean, you can make one line out of it, you can make one line out of it, or maybe if you want, you can make one line out of it. Anyway, so these 3 data points are not collinear. So the thing here is that are we looking for a line that fit over all the points, or is it possible to not even find that line? Then should we look for something else? Tell me. Yes, right? We should be looking for something else. If it is not, if the line is obviously not following on all the points, then we should be looking for something else, right? So it seems like we are not actually finding the line, right? Because there might not be even a line that exists. because it is a real world data set, right? So there might not be even a line that adjusts. So we are not looking for just one line, not looking for a line that fits all the points, because it is not even possible always, right? Because we are not looking for line that that covers all the point. So instead of that line, what we are looking for is that something like a trend, right? So we're looking for some trend. Okay, trend in the sense, trend in the sense that you may say that कि ठीक है एग्जैक्ट लाइन तो नहीं मिल रही, बट शायद ये लाइन थोड़ी अच्छी लग रही है ना? जैसे फॉर एग्जाम्पल ये लाइन थोड़ी अच्छी है ना, तीनों के पास से जा रही है. व्हाट डू थिंक? व्हाट डू थिंक, इज दिस लाइन गुड एनफ? सी, अल्टीमेटली लाइन तो चाहिए, ठीक है ना? अगर लाइन, अगर अगर लाइन इनसे पास नहीं हो रही है ना, तो ठीक है, दूसरी आसपास की लाइन. ओके, टेल मी, इज दिस लाइन गुड एनफ और दिस लाइन इज गुड एनफ? सॉरी, एटलीस्ट ये दो से तो जा रही है. Ashutosh is saying that can it be curve? I will come to that, but for now our assumption is that that x and y relationship is linear. Okay, okay. For now we are assuming that x and y relationship is linear. What do you think? Let's suppose this is the first line. This is line number one. Let's suppose this is line number two. Which line is good? First one or the second one? Okay, that's great that most of you are saying the first one is good. Why the first one is good? See, this is the first one, right? Why the first one is good and why the second one is not good is because for 32, for 32, see, ये यहाँ पे तो एरर जीरो कर देगा, है ना? सेकंड वन इज सेइंग कि यहाँ पे तो कोई दिक्कत नहीं, फॉर दीज टू पॉइंट्स देयर इज नो प्रॉब्लम. बट बाकी के पॉइंट्स तो मतलब बहुत ही, इसने मतलब बहुत ही गलत तरीके से बोल दिया ना. इस पर्टिकुलर लेट्स सपोज 31 के लिए बोल रहा है कि एज नंबर ऑफ आइसक्रीम्स विल बी सोल्ड इज बेसिकली लेट्स सपोज 135 और समथिंग, मतलब 31 के लिए बहुत कम बोल रहा है ना. तो बेसिकली व्हाट इट इज डूइंग, इट इज नॉट मेकिंग एरर ऑन दीज टू पॉइंट्स बट मेकिंग अ ह्यूज एरर ऑन दिस पॉइंट, राइट? आई मीन ये पॉइंट एक्चुअल से कितना दूर है? ये पॉइंट एक्चुअल से दूर नहीं है. सो बेसिकली द थिंग इज द थिंग इज बेसिकली we will mathematically define, obviously we have to mathematically define what is good and what is a bad line, but currently I'm just telling you some intuition, is that what we will do, we will see whatever line it is, okay, whatever line it is, doesn't matter. We will see that what is this distance, what is this distance, what is this distance. Let's suppose this distance is you call it d1, is the d1 is a good number, okay, d1 d2, and let's suppose this distance is d3. Mathematically the best line, okay, the best line or the trend, best line is some line that has minimum d1 plus d2 plus d3. Okay, minimum d2 plus d1 plus d2 plus d3, or maybe actually like unfortunately it could be plus and minus. फॉर एग्जाम्पल यहाँ पे -2 आ रहा है, मैं यहाँ पे -3 आ रहा है, यहाँ पे +5 आ सकता है, तो अल्टीमेटली मिनिमम तो जीरो हो जाएगा. मतलब लाइन बेकार हो फिर भी मिनिमम जीरो हो जाएगा, तो उनका मॉडुलस ले लेते हैं, है ना? मतलब एक्चुअली आई एम इंटरेस्टेड इन द magnitude, right? I'm not interested in the you can say in the sign of that particular d. Okay, or maybe if you want you can take a square also, because square is also positive, so you can take a square or you can take the modulus, both are fine. Okay, both are fine. I mean, ultimately I want to add some positive numbers, so ultimately I'm looking for the minimum d1 square plus d2 square plus d3 square. Is this fine to everyone? Or maybe if you want you can say minimum of d1 plus d2 plus d3. Mathematically that will be the best line for me. Getting my point? So basically, what I'm trying to say here is that if someone give you, okay, so So if someone give you this pattern, and someone asks you that, okay, what is the number corresponding to 5, right? So may I saying that what will mod do here? Mod is just for example अगर difference निकालना है किसी भी दो चीज का difference, तो I will be I will be taking the first number and the second number, right? So if I take the first number, it is greater and it is lesser. So it could be, let's suppose, it could be 2, it could be 3, है ना? First number, second number. But I mean number on this line and this number. So it could be -5. It could be -5. क्योंकि the order is different, ना? You're getting it is below, then it is positive. If it is above, let's suppose it is -5. I don't want to sum it to 0. I don't want to say, okay, the error is 0. Or if it is, let's suppose, not -5, -4, okay, then it doesn't mean that error is very less. Error is just 1. No, error is 9 actually. 5 plus 4, 9. I want to add all of this. I don't want to subtract because of this -4. Why it is -4? Because this if I'm taking this number first, number on the line, and the actual number, if I'm taking like this, then it could be minus or plus could be the difference, right? Okay, because this is the point which is above this line. So that's why I want to sum all of this. I don't want to say that, okay, this 2 3 2 plus 3 5 and this -4 is actually helping me. It is like helping me to minimize that or something. I mean it is not the accurate measure, right? I want to measure it as a 9. Okay, I want to sum all of these numbers to be 9. I don't want to say it is just 1. It will be very wrong to me, right? Okay, so basically, if someone give you 5 here and you want to predict that what is the number corresponding to 5, then what you will do, you will say that, okay, probably I have to find the linear relationship between a and x, oh, sorry, in x and y. So for example, this is y, this is x, so I want to find out the linear relationship between x and y, but it should be such that let's suppose I'm saying that maybe there is, okay, there is some a and b which is giving me this number, these numbers. For example for example if a is, let's suppose, 3, okay, or maybe let's not worry about it. I'm just having some a and b, okay. Let's suppose this is 3 and b is, let's suppose, maybe, I don't know, maybe 1, okay, anything, okay. Then it will give you some numbers, and maybe there is a case where a is, let's suppose, 3.2, b is, let's suppose, -1.2 or 1.3 or whatever, right? It will give you some number. So this is better or this is better? How you will figure out? So basically one possibility is this and another possibility is this. How you will figure out? Let's suppose it is giving you something, okay. It is giving you, instead of 2, see here, these are just some random numbers I'm writing. Don't worry about exact, okay. 3 into x, don't follow this. I'm just saying something. Let's suppose it is giving you 2.1, it is giving you 4, it is giving you 5.9, it is giving you 8.8, something like this. And let's suppose it is giving you 2.2, it is giving you 4.1, it is giving you 5.6, it is giving you 8.5, okay. Suppose something like this. Which one is better out of these two? Okay, I mean, what I'm saying, there is one possible pair of a and b, there is another possible pair of a and b, and you need to finally finalize that, okay, which possible pair is better. How you will finalize? Any idea? This pair is first pair, this pair is second pair. Anyone like to tell me that how will you finalize that which pair of a and b is working well? Okay, don't worry about this computation. Actually, I'm just writing the number. I don't know the exact a and b which will produce this, but it's just some example. So the problem statement is clear to everyone. We want to find A and B such that those A and B are the best. But how to define this best mathematically? What we will do now let's just see this, okay? What we are going to do. Okay, see, if let me just give you disclaimer. If it is seeming, too tough, then don't worry. Like, just be with me. In machine learning, it will for sure happen that you will face difficulties. Okay, so see here. See, let me tell you one thing. That Okay, do you even want to guess that when I started my machine learning, then machine learning journey, I can say, okay, because it's not a subject, it's a journey, to be honest. Okay, so when I started my machine learning journey, do you want to guess that that let's suppose just to understand linear regression, which I will just explain in next 2 3 classes. So just to understand linear regression or the basics of the machine learning, how much I struggled. Actually, 1 महीने तक समझ ही नहीं आया कि क्या चल रहा है, ठीक है। फिर एक बार लाइक लेट सपोज आई आई गॉट टू नो अबाउट मशीन लर्निंग इन वन इटरेशन, एक बार पढ़ लिया, ठीक है, ये सारे एल्गोरिथम्स हैं। फिर दोबारा पढ़ा, ठीक है, कि ओके ये लीनियर रिग्रेशन, अच्छा ये पैरामीटर फाइंडिंग है, ओके ओके, यहाँ पे ये रिग्रेशन था, ये क्लासिफिकेशन, अच्छा ओके, ठीक है, लीनियर रिग्रेशन और एसबीएम में ये रिलेशन हो सकता है, ओके। थोड़ा थोड़ा और ज्यादा समझ में आया। फिर एक बार तीसरी बार पढ़ा इंटरव्यू के लिए, तब और ज्यादा समझ में आया। सो आई कैन से कि इट्स नॉट जस्ट वन सब्जेक्ट की, मतलब डोंट माइंड मी सेइंग इट, बट एक्सपेक्टेशन मशीन लर्निंग से ये मत रखना कि ये जस्ट लाइक फॉर एग्जांपल पाइथन प्रोग्रामिंग, या फिर कोई जस्ट लाइक एनी अदर सब्जेक्ट, फॉर एग्जांपल डीबीएमएस या फिर कैलकुलस या फिर एलए, जस्ट लाइक एनी अदर सब्जेक्ट, ये एक एक ही बार में समझ में आ जाएगा। थोड़ा डिफिकल्टी होगी, ठीक है। आई विल ट्राई माई बेस्ट, डोंट वरी, आई विल ट्राई माई बेस्ट टू इवन मेक श्योर कि एक बार में ही समझ में आ जाए। बट थोड़ा सा एक्सपेक्ट करना कि ये एक बार में समझ में हो सकता है नहीं आए। हो सकता है कि आपको यू जस्ट नीड टू टेक इट विद अ पिंच ऑफ सॉल्ट, विच मीन्स कि आपको एक बार में समझ में नहीं आए, लेकिन उस पर स्टक नहीं रहना है। ओके, डोंट डोंट लाइक कि हाँ इसको समझ के ही नेक्स्ट लेक्चर में मुझे जाना है। ओके, डोंट डोंट बी लाइक दैट। समझ में नहीं आया है कोई पर्टिकुलर चीज, इट्स ओके। ओके, आप एक बार नेक्स्ट लेक्चर देख लो, बिकॉज इट इज अ वेरी डिफरेंट सब्जेक्ट फ्रॉम एनी अदर ट्रेडिशनल सब्जेक्ट दैट वी हैव स्टडीड। वहां पे एक बार में समझ में आ जाएगा, यहाँ पे हो सकता है कि एक बार में समझ में नहीं आए। तो अगर समझ में नहीं आ रहा है तो उस लेक्चर को अच्छे से देखो, बट जस्ट मूव टू द नेक्स्ट लेक्चर। ओके, अंडरस्टूड। सो बेसिकली डोंट जस्ट स्टक ऑन द लेक्चर दैट नहीं, यह समझ के ही दूसरे लेक्चर पे जाना है, या फिर ये पर्टिकुलर टॉपिक समझ के ही दूसरे दूसरे टॉपिक पे जाना है। And again, it is going to be little bit, not just little bit, it will be quite mathematical heavy, but at the same time I will make sure that you are getting the things very much in the very first flow. Okay, so you will be getting everything, mostly everything, in the sense mostly most of the things in the first flow. But again I am saying, if you are not getting something, okay, don't doubt yourself, don't doubt on me। ओके, यू शुड नॉट आइदर डाउट योर सेल्फ दैट ओके कि पता नहीं, मतलब मेरे ही समझ में नहीं आ रहा, या फिर ऑल्सो डोंट डाउट ऑन मी कि पता नहीं कि लाइक आई एम नॉट एबल टू एक्सप्लेन प्रॉब्ली। ओके, मे बी both are on the right track, maybe I'm able to explain, maybe also you are able to get, but the nature of the subject is quite different from any other subject। Okay, so just have some faith, and don't treat it as a subject, it's actually a journey। 2 महीने we will study machine learning, and in these 2 months you just have to sometimes go to the next topic, even if you're not getting, and then later you will realize कि वो अब समझ में आ गया है। ओके, सो दैट्स बिकॉज द नेचर ऑफ द सब्जेक्ट। आपको बाद में समझ में आएगा कि हाँ अब समझ में आ गया, ठीक है। जो पुराना लेक्चर था वो हो सकता है कि 2 क्लास के बाद में समझ में आए थोड़ा थोड़ा। ओके, इट माइट सो हैपन, आई एम टेलिंग यू बेस्ड ऑन माई ओन एक्सपीरियंस। लाइक नॉट जस्ट मी, लाइक इफ यू टॉक टू एनी वन who has enough experience on machine learning, उनसे आप पूछोगे, they will tell you the similar story। machine learning is a subject that you can't just get in one flow। ओके, आई मीन 100% हो सकता है समझ में नहीं आए, तो दैट्स फाइन, ठीक है। नहीं आ रहा है तो इट इज ओके। एनीवे, लेट्स जस्ट कंटिन्यू विद दिस एग्जांपल, ठीक है। So what I'm saying, that you have two possible pairs of A and B, and ultimately you want to know that which pair is suiting you well. Then what you will do is something like this, right? You will say कि for example, just a second, okay, just give me a second, let me just copy paste it। Actually, I'm just writing it separately. Just 1 minute. So this is the first pair that we have got. This is second pair. Okay. I'm just writing both pairs on the separate tables. Okay. Anyway, so just tell me the difference between the real one. So this is the real. Okay. This is the real which I already have. This is what my model predicted, right? I mean, this is the relationship that my model thinks, right? This is the model output or the model prediction. Okay. I mean, let's suppose the model is saying A and B is this, then suppose A and B are actually these are the numbers that we are getting. These A and B could be different for to produce these numbers, but I don't have exact numbers as per me. I mean, as per this lecture, so I'm just assuming there is some A and B which are giving you, let's suppose, these numbers. So what you will do, you will see that what is the difference between the actual y and what your model predicted or what you predicted, right? So you will see you can take anything. You want to make me this minus this, which means the predicted minus actual, or actual minus predicted. You can do anything. Actually, eventually I want to take square, okay, or you can take modulus, whatever. So कुछ भी कर लो, ठीक है, क्योंकि वो माइनस प्लस का चक्कर मैं नहीं चाहता. तो what you want, predicted minus actual or actual minus predicted? So this is, let's suppose, predicted, that the model predicted. This is the real. This is the actual one, जो actual sale हुई है. Let's just do anything. Maybe predicted minus actual, right? Doesn't matter actually. Okay. So predicted minus actual, anything. So 2.1 minus ये 0.1 आ गया. ये 4 minus 0.1 करोगे, minus 0.1 आएगा, right? Minus 0.1. 5.9 minus 5.7 करोगे, 0.2 आएगा, I guess. If you do this, then it is 0.4. Okay. I don't want to add all of this because this will minus plus. I don't want to cancel. So that's why let's just take the modulus before adding. Okay. Okay. You can take the modulus, or maybe you can take the square. Which one you prefer? To take the modulus or to take the square before you add? I don't want to add directly because this minus plus get cancelled. It is actually helping. Okay. This minus is helping it. So you can take anything. Doesn't it won't really matter. But okay, most of you have suggested modulus because it is good for human. But let me just tell you, it is not good for machines. Okay. Square is actually better for machines. Why? Because we will be dealing with the optimization, and modulus function is not differentiable. I mean, modulus is not wrong. Okay. It is definitely correct. You can work with the modulus with the some of the tricks, but why to complicate the things, right? For the machine, squares is actually better. X square is differentiable everywhere. Modulus function is not differentiable. So we actually need to differentiate those things. I will tell you later on. So that's why let's just take the square. Okay, let's just take the square. I mean, you can take the modulus. I'm not saying, see, again, I'm not saying that modulus is wrong. I'm not saying modulus is wrong. It is little inconvenient, making our things little harder. Why to make things complex, right? Okay. Now let's just talk about it. So what about this? It will be 2.2 minus this. It is zero point 0.2. This is 0. This is minus zero point 0.1. This is 0.1, right? Okay. I think out of this, which one is, देखो 2.2 square इसका भी हम करेंगे, ये भी करना होगा, ये भी करना होगा. So I think these three will match. If I add just these two, it will be it will be little more. I think this will be zero point 0.4 square more, right? I mean, zero point 0.4 square is an extra term here, as I can observe, right? So it is giving me, this first version is giving me more overall, more error, isn't it? See, if you compare this first A and B pair or the second A and B pair, actually you can call them different models because A and B are different. So if you compare model 1 and model 2, okay, don't worry, we will have those terminology clear later on. It is just today is just introductory lecture. So don't worry about the model, don't worry about the train set, don't worry about this square. All of this will get clear. It is just a motivating example for all of you. So just tell me which model is better, model 1 or model 2? Model 2 seems better because here the overall squared summation of the error, let's just call it error. Okay. This is the error that you are incurring. In technical terms, it is also called a squared error because we are taking the square. Okay. This is also a squared error, right? So you can say squared error of model 2 is less, right? Isn't it? Since the square error of the model 2 is less, so compared to model 1, right? So compared to model 1, model 2 is better, right? Is this clear to everyone? So basically, ultimately, model 2 is doing what? These squared, right? I'm basically taking the square. Let's suppose this is a model 1, or maybe let's suppose this is a model 1, this is a model 2. Okay. So model 2, or maybe let's vice versa. This is 2 and this is 1. This 1 is actually giving me more error. Okay. Suppose this 1 is actually giving me more error, 2 is giving me less error. So I will ultimately say that okay, 2 is better, or something like that. Is this clear to everyone that what we are doing? So mathematically, we are actually from just intuition, we are going in a way to develop the mathematics. So mathematically, I need to know to quantify it that what is better, right? Now, what will I do? Given any problem statement, for example, let's come back to this ice cream sales. Given this problem statement, what will I do? I will say that let's assume, so basically let's just write all the steps for the final machine learning algorithm that we need to have for this particular problem statement. So we will say given this, let's just assume the relationship between you can say by and x is this. Let's just assume this is the very first step, that I'm assuming the relationship is linear. Okay. Now what is the next job? Find a and b such that the final line best fit in the data. What do I mean by best fit? Let me first write it. Such that final line should best fit. Can anyone tell me what do I mean to say best fit? For example, if I have two pairs of a and b, then I will compute. For example, let's suppose this is x1. Okay. This is x1, this is x2, this is x3, right? This is y1, this is y2, this is y3. These are the real y. Okay. But it your model will also give you y. Let's just call it y cap 1. Okay. Y cap 2, y cap 3. Is this okay to everyone, like this notation? What is this y? Y is the real y that we have. Y cap is basically the model prediction, right? Model prediction. Okay. So what do I actually want? Ultimately, mathematically, what do I want? Keep whatever model is giving me, I'm calling it, let's suppose y cap. Okay. So, okay, sorry, you can call it y cap. Okay, notation, I will fix it in the next class. Okay, whatever notation we are going to use, we will continue with that notation in the entire series of these lectures. So basically what I want, that by 1 cap minus y, this is the error square, right? Plus y 2 cap minus y square plus y 3 cap minus y, sorry, y1, y2, y3 square. So basically y1 is nothing but, y1 cap is nothing but a uh, x1 plus b minus y1, right? Matlab basically whatever the model is predicting and what is your real ground truth, that's also called ground truth or the real value. Okay. The difference between these two plus. So this is the first error, second error, third error. I want a and b such that this whole term is minimum, isn't it? Is this mathematical formulation is clear to everyone? So what we are looking for is actually we want a and b such that this whole term is minimum, right? We are looking for a and b such that this whole term this summation, this is a scalar number, right? Do you think it's a vector or this is a scalar? This whole thing. What do you think? The scalar number, right? So we are looking for a and b such that this complete term, right? This what do I call it? Can I call it a squared error E? Or maybe let me just call it L. Okay, some loss. Okay, so such that this loss or L, or maybe let me not write the name. This complete term is minimum. Oh, tell me, do you have this x1 with you? Do you have this x1 with you? Do you have the y1 with you? Yes, x1, y1 both are with you. Okay, I mean x1, y1 is obviously there. You just need to get a and b, isn't it? So if you put this x1, this will be 25a plus b minus 108 square plus 28a plus b minus 120 square plus plus uh, x3 is 31a plus b minus 140 square, right? So basically, you have obviously your a and b. This bicep is just a dummy notation that I have used, but it's not in the formula, okay? Because bicep is nothing but x plus b. So you have your x1 y1, and we have plugged it into that. And now this is just a, you just have two choices between two pairs of a and b, or just a whole choice of numbers. A could be any real number, b could be any real number. See, in the toy, just to explain this toy example, I just told you, okay, let's suppose you have two pairs of A and B. But do you have two pairs of A and B here? No, right? For example, this is the pura R2, right? So, for example, let's suppose I want to minimize x square plus 3 or something like that. So, it's like कि हाँ x am I saying कि okay कि x equal to 1 better है कि x equal to 0 better है और x equal to 2 better है? Are you comparing like this? X equal to 1 पे it will be obviously 4, it will be 3, it will be 7. So, which one is best among these three? X equal to 0 equal to best, right? X equal to 0 because it is giving you 3. It is best. But in real life, do they actually give you the choices, or you have to differentiate and find out the value? I mean, they don't tell you like this, right? You have to differentiate and then you find out the value. So similarly, it was just one example where I was just saying कि हाँ मतलब दो choices हो क्या होगा, but you don't have two choices of A and B. You have whole set of A and B, right? All the real numbers. So what you will do? This is called a function, and more specifically, this is a function of a and b, right? This is a multivariate function. If you know about the multivariate function, it is okay. Otherwise, don't worry. We will be going step by step from the next lectures, even more, more as a beginner. But if you know this, then this is just a function in two variables, right? Have we seen the differentiation, how to differentiate a function in two variables already in the calculus, in the multivariate calculus in the module 2? Yes, right. So basically you now you have a function. Now you have a function, right? And this function is actually, yeah. So this function is actually giving you, I mean, this is a multivariate function which is basically asking you to find out the values of a and b such that this function is minimum. Okay. So anyway, let's not worry about it. So basically we want to minimize this function, right? Great. So we want to minimize this function for a and b. Once we minimize it, we will be having some a and we will be having some b, isn't it? Do you think it's hard to minimize this function? To be honest, it's easy, right? See, this is a function, and now if you want to minimize, it's actually easy. मतलब पार्शियल डेरिवेटिव लेना है ए के रेस्पेक्ट में, बी के रेस्पेक्ट में, दोनों को जीरो करके दो इक्वेशन, दो अननोन, एंड देन यू कैन फाइंड आउट, राइट? अनकंस्ट्रेंट ऑप्टिमाइजेशन बोलते हैं इसको, राइट? So we call it unconstrained optimization. So you can, I mean, those who know the calculus already, you can just partial differentiate with respect to A, partial differentiate with respect to B, and then you can find out there will be two equations, two unknown, right? And then find out A and B. So basically what I'm trying to say here is that given this particular function, it's not very hard to find out A and B. Like if you know little bit of calculus, right? Okay, why do we want to differentiate? Because we want to minimize this function, right? To minimize this function, we have to differentiate. Understood? For example, if you want to minimize x square plus 3, you will be differentiating it, right? You need to differentiate this. Make it 0. So from here, you will be getting that, okay, x equal to 0 is your answer, right? It is minimum. And obviously, there are second order tests which will tell you whether it is minimum or maximum. So similar kind of a story you need to do here. Is this understood to everyone that how to find A and B? Okay. Even, even it is not very important to know that how to find A and B. It is even more important to understand that why and how this formulation is even making sense. So what we are saying that there is A and B, right? I don't know what is A and B, right? So basically what we are saying, there are A and B. I don't know what are these A and B. This my model will give me this output, right? My model will give me this output. I am doing what? I am summing up all the all the examples that I have, right? So let's suppose I have n examples for, I mean, or maybe 10 examples, okay? So I will say that my model will give me axi plus b. For x1, it will be giving me ax1, and then real ground truth is actually y1, okay, or yi, then whole square I equal to 1 to n. This is a function in a and b, and I want to minimize this function. I want to make them 0, and then I want to find a and b, right? This is the function that I want to minimize. Is this okay to everyone? ओके, सो आशुतोष इज सेइंग फ्लैट लाइन है, स्ट्रेट लाइन है, तो उसका मिनमैक्स कैसे फाइंड करेंगे? दिस इज नॉट वी आर फाइंडिंग द मिनमैक्स ऑफ द स्ट्रेट लाइन, ओके? दिस इज डिफरेंट फंक्शन, दिस इज डिफरेंट फंक्शन, वी आर नॉट फाइंडिंग द मिनिमम और मैक्सिमम ऑफ दिस लाइन. ये लाइन का मिनिमम मैक्सिमम का कोई सेंस नहीं है. हम एक नया फंक्शन इन्वेंट कर रहे हैं जो इस लाइन के यूज से इन्वेंट हो रहा है. अंडरस्टूड? मतलब हम ये डिफरेंस ले रहे हैं, उसका स्क्वायर कर रहे हैं, ये फंक्शन क्वाड्रेटिक है, ये फंक्शन लीनियर नहीं है. For example, this function is definitely a quadratic function. Okay, maybe something like this, and that will be in the 3D. मतलब A, B और F तीन एक्सेस होंगे इसके. But it's not much important कि मतलब like कैसा ये function दिखेगा. But yeah, this is a quadratic function. This function is not a linear function. The final loss function or the squared error that we are having, it is not linear. Okay, it could be very different from your model model shape. Okay, I mean whatever your output shape, that is very different from your loss function shape. These two are nowhere related. Okay, so anyway, is this okay to everyone that what we are doing? So what was the problem statement? We wanted to find out something like a and b, right? A b find करना है because my model says that ax equal to b. Okay, my model says this ax equal to b. ठीक है, बाई कैप अच्छा नहीं लग रहा हो तो नोटेशन का इतना टेंशन नहीं है. मतलब ये मॉडल आउटपुट है. ओके, ये मॉडल आउटपुट. My model says X equal to B, but real, I always have, because I'm training, right? That's called training. I always have my real output, which is given to me. Okay. So I will just compare this model AX plus B and whatever I have by. So for example, for example, for X1, for X1, if this is data, I have by 1, right? For X2, I have by 2. For X3, I have by 3. I mean, this is the training. Because since this is a training, that's why I have all of this. Now my model will give me something. What my model will give you, can anyone tell me? For here, this is the pair of x and y. For x1 y1, what will my model give? And this is the model output. Okay, so for x1 and for x1 my model will give me ax1 plus b. Here it will give me ax2 plus b. Here it will give me ax3 plus b. Here it will give me ax4 plus b. Okay. This is my model output. This is given to me. Is this clear to everyone? This pair is given to me. Right? This is my model thinks that it should be the case. Then I need to find A and B such that these differences I will find out. I want to minimize these differences, isn't it? So basically, I want to minimize this ax1 plus b minus y1 square इन सब का समेशन लेके ऐसा ए एंड बी फाइंड करो जो इन सब के समेशन को मिनिमाइज कर दे. दिस इज जस्ट वन क्राइटेरिया. यू कैन कम अप विद अनदर क्राइटेरिया विच इज फाइन, बट यहाँ पे हम स्क्वायर्ड एरर एज अ क्राइटेरिया ले रहे हैं, विच मीन्स आई एम टेकिंग द स्क्वायर एंड आई एम डूइंग द डिफरेंशिएशन. अगर मैं मॉड लेता तो डिफरेंशिएशन इजी होता क्या? ओके, सपोज आई एम टेकिंग मॉड एवरीवेयर, देन इफ आई एम समिंग देम अप, सो उसके बाद मुझे अल्टीमेटली डिफरेंशिएशन करना है. रिमेंबर, see, ultimately I want to differentiate. If I'm taking the mod instead of a square, okay, if I'm taking the mod instead of a square, it will not be easy, right? So maybe somehow I can do it. Maybe I need to put conditions, and there are like a lot of tricks I need to play, but it's not easy. So why to make our life difficult? That's why people only prefer square. Okay. Okay, because a square is also not wrong. So is this clear to everyone that what is the problem formulation and what we are trying to do here? Right? So basically, someone gave me XY. I told that person, okay, you want me to find out the relationship between X and Y? I think the relationship is this, right? I think the relationship is AXB, AX1 plus B. Now you will say that, okay, it is not exactly equal to Y1. It should be, see, in ideal case, it should be exactly equal to Y1. It should be exactly equal to Y2. It should be exactly equal to Y3. It should be exactly equal to Y4. In ideal case, this should be exactly equal to y1, which means this difference is 0. This should be exactly equal to y2, which means this difference is 0, right? So in this is just ideal case. Okay. So in ideal case, this is y1, this is y2, this is y3, this is y4. Is this okay? This is y1, y2, y3, y4. In ideal case, these are 0. But it might not, my data might not be exactly on the line, right? There are many reasons behind it. बहुत सारे रीजंस हो सकते हैं. फॉर एग्जाम्पल आइसक्रीम सेल्स में ऐसा हो सकता है कि मतलब देर कुड बी मैनी रीजंस. वन ऑफ द रीजन कुड बी कि जब बंदे ने काउंट किया कि यार 31 आइसक्रीम सेल हुए हैं, हो सकता है ही माइट हैव काउंटेड इट रॉन्गली. ओके, in reality there could be 30 ice creams that have been sold, but maybe he counted wrongly. This is one case. Another case could be he might have measured the temperature wrongly. Another case, maybe 35 temperature tha, he might have measured it 36. Another case could be data inherently is even he counted correctly, even the measurements were perfect, all the things are okay, still the data is not following exact linear relationship. Okay, so there could be any case. I mean, in practical there could be any case. Let's not worry about it. You will get to know slowly everything. You will get to know slowly. Don't worry, don't get fear from this first lecture. Okay, I was not actually thinking that I will go that much mathematical, but anyway, then I thought that okay, little bit mathematics flavor I should be touching, right? So that you should be getting the idea of machine learning, that what we want to do. So basically, ideally I can say in the ideal case, okay, these are the ideal case. This is the ideal case. In ideal case, this should be by 1, this should be by 2, like this, but in reality it is not by 1, it is not by 2, it is not by 3, it is not by 4. It is approximately, okay, it is approximately by 1, it is approximately by 2, it is approximately by 3, it is approximately by 4. Then how much close this is to by 4, I need to check it. How much close this is to by 3, I need to check it. How much close this is to by 2, I need to check it. How much close this is to by 1, I need to check it, right? I need to check how much close these are to each of the corresponding values. How will I check it? Take the difference, very simple, and square it. Take the summation. Find out the a and b that give you the best line, in the sense that give you the minimum squared summation. Okay, it is just, eventually it is just an optimization problem. Understood? So actually, this is exactly called linear regression. This is a single dimensional linear regression. So ideally, I can say we have just covered, okay, the very first topic here, simple linear regression, right? I mean, obviously, we will see in more detail, we will see more examples, but yeah, you can say that, okay, we have covered simple linear regression. This is the simple linear regression only. Okay. We have just covered one topic. Obviously, this is, I'm not counting this as a simple linear regression lecture. I'm just counting as a motivating lecture. But in reality, this is the simple linear regression. So what is a simple linear regression, or what is a linear regression? Basically, you assume that, okay, there is a linear relationship. It could be x1 plus b. Ideally, it should be y1. Okay. I mean, these two should be same. Then only I'm assuming that model is giving this output. But how much these two are close will be given by this quantity. How much these two are close will be given as this quantity, this quantity, this quantity. I want this to be minimum, this to be minimum, this to be minimum, this to be minimum, which means I want summation of all of this to be minimum. So let's just sum it. Let's just find the minimum, and let's just find A and B, right? That's all. That is all about your linear regression. Or you can say you have just got the nutshell of the machine learning, that what machine learning is trying to do, right? It is just trying to optimize few functions. It is just trying to find out few parameters that will help us to minimize some loss function or minimize the error. Have you understood the crux of machine learning, that what we are trying to do here? Let me know. Okay. Little bit. Okay, if it is too heavy, don't worry. We will be having more examples. You will be getting to understand more. Don't worry, right? So little bit you might have got it, that what we are trying to do. Okay. Okay, great. So that is all I wanted to cover today. Let's just continue tomorrow. Okay. If there is any doubt, you can just ask me. So Ajay is saying, sir, can you please explain the difference between AI and ML? Uh, See, these differences are actually very theoretical differences. Nobody cares about these differences, and so on. Or like in theory, people say that AI is a broader domain and ML is a smaller domain. But nobody really cares about it. I mean, बस ये बोलने की बात है. कुछ difference नहीं है as such. Okay. मतलब ऐसा कोई पूछेगा नहीं कि क्या difference है and all. Basically, earlier people used to call it AI, but then they found out that, okay, more mathematics is there, more, like optimization, these kind of things is there. So they started calling this kind of area as machine learning, and the traditional AI algorithms were there. For example, A star algorithm, or there are some traditional algorithms that were there earlier. So they used to call that AI, and then now they completely call it AI. Anyway, like these are just theoretical definitions, doesn't really matter. Okay, just is asking, sir, the function is defined by us or the machine? This linear relationship will be given by us. Machine will give you A and B. We will write the algorithm in such a way, it will give you A and B. What is the linear relationship? Is it quadratic, linear, whatever the function, we need to define it. Machine will just give you the parameters. Okay. Is there any book suggestion? Yeah, books are definitely there, but in the next class I will list out the books. Anyway, I'm planning to do it, but actually I will not recommend to read any of the book. Reason being is that you will not be able to understand it, and neither it is required. Okay, it's unfortunately that books are not made for the beginners in machine learning. Okay, unfortunately, I mean the standard books that are heavily popular books are very mathematical. These are not made for beginners. Any of the book, for example, there's a book called Bishop. This is highly popular book. There's a book called Statistical Learning, something like that. I forgot his author name, but yeah, there's a book called Murthy. I mean, the author name is Murthy. So these are there are few books which are very popular. People use them, but those are not beginner friendly for sure. I will list out the books name in the next lecture. I will give you the problem. So just is asking how to solve for problems for ML and ML like ALA probability DBMS. I will give you the problems. Okay, cool. Is there any other doubt, sir? Does machine learning models predict the trend by reducing the error previous data instead of direct prediction? we are calculating loss. Is it because of the inconsistent system? No, we don't need to check whether it is consistent or inconsistent. Doesn't worry. If it is zero, then machine learn A and B will be such that see, consistent system is just mean that it is zero, right? I mean, it is exactly equal to y1, it is exactly equal to y2, it is exactly equal to y3, it is exactly equal to y3, y4, right? Sorry, this is y3, this is y4. So if it is consistent, then anyway this error will be zero. And if we are trying to minimize, then it will automatically find out A and B such that this is zero. So you don't have to worry whether it is consistent or inconsistent. If it is consistent, then automatically the error will come out to be zero. Oh. So if there is any other doubt, then please let me know. Okay. So thank you everyone. Thank you so much for attending today's lecture. Thank you for attending. Let's just meet tomorrow. Okay. Yeah. So Ashutosh is saying today it was fun. Thank you so much. Take care.